first. All right. And annotate. All right. So the picture doesn't really matter at this point because all the information is technically here if you read it. We have a diameter of 2 feet. It's a cylinder. Oh, it's a cylinder. It has a diameter of 2 feet. All right, as shown as this figure above, which the same information. The water drains out. Okay, the water drains out, so water comes out. So we should have less. They gave you the rate of change of the height. H is height, T is time, obviously. And they even nice enough to give you the formula for the volume of a cylinder. All right. Now, at this point, it doesn't really matter if they give it or not because you have access to Google. You can look up the formula if you needed to. All right. So take advantage if you're taking the AP exam that you can Google formulas. I suggest you have your formulas in front of you already. All the formulas that you need should be in front of you. Any theorems in front should be in front of you at that point. So part A, find the rate of change of volume. So that automatically tells me that is what I'm looking for. And they were nice enough to give this volume formula. All right. So clearly we need to take the derivative of this equation. Now I told you guys this before, this is the harder part. Before you take the derivative, I noticed that there are two variables there, which will lead to dr dt eventually and dh dt. All right. Now clearly I need to have both of these so that the only thing missing would be dv dt. So the question is, do I have both of them? Well, dh dt, they gave me this equation right here, so I can figure it out as long as I know the height. Dr dt, I don't know yet. Can someone tell me what they know about dr dt here for this particular problem?
Is it constant?
It is a constant. Specifically, what number? What's the rate of
1
change?
foot or something? No, wait, no. Wait.
What's the rate of change of radius is essentially
0.
what you're asking. Thank you. That is 0. All right. So I have everything I need to keep going. All right. In fact, there are two ways to approach this problem. I will show you the fastest way. The fact that the radius never ever changes is always 1 foot. No matter where you are, no matter what height the water is, it always is 1 foot, no matter what. So that means I can actually go ahead and plug in 1 foot from the very beginning of the equation before I take the derivative. So I want you to make sure you understand the only reason I can do that is because the radius never ever changes no matter what level the water is. All right, it's always 1 foot no matter where you are. The radius is always 1 foot, and that's why I can do that. If the radius changes, I cannot plug in that number. All right, I have to actually do the product rule. All right, you can do the product rule if you want to, and you know dr dt is 0, but this is faster. So actually my volume formula is going to become just pi h. You got questions so far? All right, so this is actually pretty easy. What is the derivative of that? And you have to think of with respect to time because it's implicit. That'd be dv over dt here. Pi is just a coefficient, so I'm leaving it alone. The derivative of h is 1, but don't forget dh over dt because you took the derivative with respect to time, and that did not cancel out. So dh dt, we don't have a specific number, but we do have this equation right here, which is -1/10 square root of h. Are we okay with that? Anybody got questions? All right, the last step, dv/dt. We have pi, you have -1/10 square root. Now, what height is the water in this particular problem? Do we have that information?
4 feet.
4 feet. They told us right here. 4 feet. So I put 4. Do you have questions? All right. Now, this is a free response. My question to you at this point is, can this be typed in a calculator and it will give you a numerical answer? Can you actually plug that in the calculator and it'll give you a numerical answer, a number? I'm not asking you to actually do it though. I'm not asking you to actually put in the calculator. My question is, can it be put in the calculator and would the calculator give me a number? Yes or no? All right, somebody's got to say something.
I'm gonna say yes.
Yes. All right, yes, you can simplify that yourself, but it is totally unnecessary in a free response. They will accept any form of the answer as long as if you put in the calculator, it should give you a numerical answer. This is good enough. You don't actually have to even simplify it further than that. But don't forget one more step. It says units of measure. So we are not done. You have to actually write down what's the unit. This is volume over time. So what's the volume for this problem? You should know your geometry. Volume should be units cubed, right? So it should be feet cubed per and time. So it's the volume part. And how much time? Time is measured in what in this particular problem?
Seconds.
Seconds. Is Nelson the only one speaking here? All right. And that is good enough. I'm trying to save you time in the AP exam because you don't actually have to simplify all the way. This is good enough. I know you could have gone -2 pi over 10, which is -pi/5. I know you could have done all that, but I'm telling you, it is not necessary. All right. You could have stopped right here at this moment because that is a numerical answer. If you actually put in the calculator, that's good enough in a free response. Questions? All right. Like I said, do you guys want me to show you the other way? If you actually did not plug it in, and what if you actually solve for it with the product rule? Do you actually want that, or we want to skip that? I need actual answers here, not just from Delson. You know, there's quite a few of you here. Hello?
I can skip that.
Skip that. All right.
Yeah.
So if we're going to skip that, we can go straight to B then. So let me erase all this and clear all this out. I'm going to go to B then. Part B. When the height is 3 feet, the rate of change of the height of water with respect to time, so that's dH/dt is what they're asking for, or H prime, increasing or decreasing. So they're asking if this will be increasing or decreasing. That is what they're asking for. All right. So you need to actually understand what would cause that to increase or decrease. Now, if you remember, I made you guys write down justifications before. For example, how would you know if the function f is increasing? What would be the justification for that? How would you know f is increasing? Do you guys remember how to justify? All right, like I said, someone's got to say something here. This is not a one-sided discussion. How would you know if a function is increasing?
Positive slope or something like that.
The slope is positive. I agree with you, but make it more calculus. The justification, make it more calculus, not just straight out the slope is positive.
First derivative is positive.
The derivative, because specifically f prime is positive, right? You remember doing that?
Yep.
All right. So we're
Yes.
applying the same concept here. So we're gonna say h prime is which is dh dt really is increasing. We know that if and as you can see, that's a function. We have to look at its derivative to figure it out, right? So this is what we got to work with. So we got to look at its derivative to figure it out, which is also known as this notation. It's what we're looking for. If the second derivative is positive, I know the first derivative is increasing. All right? If the second derivative is negative, then I know the first derivative is decreasing. Okay? So clearly, to figure this out, I need to find the second derivative. That is the goal here for part B. I need to find the second derivative. Positive, then I know the rate of change of the height with respect to time is increasing. And if it's negative, then I know it's decreasing. So that's my goal. So they already gave me the first derivative right here. So my goal is, what would the second derivative look like? Well, -1/10 is a coefficient, so I'm leaving that alone. You have to remember this is the same thing as h to the power of 1/2. So what's the derivative going to look like? Oh no, someone tell me what's the derivative?
1/2 h to the -1/2 or something like that.
That is exactly right so far. That is not quite done. 1/2 h to the -1/2 is correct so far. That is a correct answer if that was respect to h, but this is not respect to h. If this was respect to h, then you said you took the derivative of h with respect to h, and that's why nothing's left. But you took the derivative of h with respect to time, and it stays there. All right, that's where the dHdt pops up. So you end up with -1/20, and this right here is 1 over the square root of h, and dHdt, we have this equation to replace dHdt, which is -1/10 times the square root of h. Anybody have questions so far with that? All right. So I want to know specifically at a height of 3 feet. So that means this, such that h is specifically 3, will become negative times negative, which is positive. So that's +1/200. And we have this and this. Actually, what happens to that? What happens to these two when you actually multiply them? I'm waiting. Somebody say something. One.
They cancel out.
They will cancel out to 1, right? So actually, the second derivative, and this doesn't even matter, the second derivative is always 1/2 200, which we know is a positive number. It's not a very big positive number. It's a tiny number, but it is still positive. All right, as you can see, it's always 1 over 200 no matter what you plug in. So it's always positive. So this is a true statement without that that symbol. All right, since I know the second derivative is positive, then I can say that dH dt, or if you want to put it in words, the rate of change of the height of the water with respect to time is increasing because dH or d square h over dt square is positive. And I don't have to mention in this particular instance, I do not have to mention specifically at h equals 3 because this is true no matter what h is. I was going to mention it right here, but there was no variable at the end. It was always 1 over 200, so it doesn't matter anymore. It's true no matter what. Does anybody have questions? All right, if you have no questions, then I am done with 4A and B. Part C is separation of variables, even says so right here. And that is not until later on unit 7. Right now we're reviewing unit either 3 or 4. I forgot which one. But it's about implicit and related rates right now. So we're not doing that until later on. Anybody got questions that you want to talk about at all? Anything? All right, if you got no questions, I'm done for the day. I'll see you guys tomorrow. You got some practice right here. Like I said,
That was fast.
yeah, like I said, I'm not trying to keep you here long unless you got questions. Clear this right here. As you can see right here, you are going to practice an implicit and related rates and delta math. You also got this to practice on if you are actually practicing for the AP exam. I gave you the links right on the Google Drive itself. All right. And we'll go over that tomorrow for those of you who are practicing for the AP exam. And if you still got questions while you're doing this assignment, we can talk about it during tomorrow's Zoom conference as well. Now, these times are not random, okay? I need to specifically use these times and those specific days because, like I said, they gave us a schedule. Math is only allowed to have Zoom on Friday at 8 to 8:45. That's it, all right? So those are not random times. It's specific times I have to follow for Zoom, so it doesn't conflict with your other subjects. Questions? All right, if you got no questions, I'm done. See you guys tomorrow.
All right, see you, man.
See you.